underway? All right, well, welcome everybody. We've got another exciting meeting lined up for today about something that has been on my mind a little bit, which is charging infrastructure. And the reason why it matters is we have to think about charging and hopefully rapid recharging of electric vehicles of all types. But we also want to think about what protocols we use, because we've already got literally hundreds of aircraft manufacturers out there. And what we want to get away from is having hundreds of different charging protocols. And so it's worth our time, I think, to start to talk about what are the protocols that are being discussed, what's out there, what's the best match for what the OEMs need with what the chargers can do, and how do we narrow down the field if we can to, ideally one type of charging or as few as possible, so that when we get to a vertiport, there isn't a scramble to find different types of adapters and things like that. And my background is in corporate jet sales, and what comes to mind with me is that the OEMs for corporate jets, they have a lot of different types of tug apparatus that attaches to the nose wheel. So if you're pulling a Learjet versus a Gulfstream, you got to have this different type of device. And it was always a scramble at the fixed base operations to find the right type of device to pull these aircraft around. Sometimes you didn't have it. It was kind of a project. Similarly with electric vehicles, it's getting better, but the day was, if you had a Tesla, you went to the Tesla charger. If you had a Leaf, you needed to find CHAdeMO. And for everybody else, it was, I think it was J1772, but there was at least 3 kinds, and there was some complexity there and a lot of adapters and so forth. So it's worth our time talking about what's out there, and then learning about what the chargers are capable of and what the OEMs need, so that we can create a matchup. So the timing is great on this, because we've got Grant Fisk with Volatus Infrastructure with us. He's going to talk first, and his company is working on building out vertiports, and is making a lot of progress, and has some cool announcements about their chargers as well. So he's going to just talk briefly about the progress they've made there. He'll have much more to announce as time goes on, but I just wanted him to touch on what they've been doing, because it's great stuff, and it's going to make for a nice package with their whole combined with their whole infrastructure package for the vertiports. And then we'll hear, we've got a video from Electro.aero. They're based in Perth, Australia, so I'm hoping they're all asleep right now, but they were very kind to put together a video for us about what they've been up to. And then it's a good overview of the different types of protocols and chargers that are out there and stuff that we can really learn from. So Grant, if it's okay, go ahead and share your screen when you're ready. Just give us a brief overview, if you can, about what you guys have been up to at Volatus. I know you've got a lot of things going on with both the vertiports. I've seen a ton of partnerships announced, LOIs, things like that. And the things you've been working on with the chargers is really cool as well. Are you having luck sharing your screen?
Well, I know I see my thing here. Can you see it?
I can't yet.
Technology is really not my friend some days. Okay, I've hit share screen.
Okay, and maybe it's just me. Suzanne said we see you. Can everybody else see Grant's screen?
I can see Grant, just not on his screen.
Good grief. All right, so we're gonna, not the screen, just Grant. Okay, I'm gonna hit share screen, little green button there.
Yeah.
And then I've got this up. Can you see the big Volatus logo?
Not yet, but we see a beautiful bald Grant.
Oh, good grief.
And that's
even
even better.
Last time.
I know, everyone, this is how it works. We
just did this.
Yeah.
Let's try one more time then.
You're doing it. You're doing it.
Yay!
Beautiful.
Thank God this works.
Just go to slideshow and full screen.
Slideshow and then from beginning. There we go. Got it?
Well done, sir. Well done.
All right.
The floor is
We'll
yours.
skip through the first part. The first part's boring. You've all seen my logo before. All right. So yeah, we are working on it. We finally officially started production of our charging stations. Now, we've been working on our charging stations for a long time, probably since even before we announced Oshkosh last year. We knew there was going to be a need for a charging station that was designed first for eVTOL usage. The energy needs for eVTOL aircraft are massively different than anything else out there. And we've talked to several OEMs. We've got 4 OEM partners, including SkyDrive, in Kiska is here with us today, which is fantastic. We're going to be working on providing charging stations for. We're working with a number of our existing partners and also OEMs that are not partners yet, but at least kind of we're having discussions with them to understand what direction they're going in terms of what their charging needs are and what charging protocols they're thinking about. What we've seen so far, there is a general consensus. It's not quite everyone yet, but it's easily more than half the OEMs we are partnered with and have been talking to are going in the direction of the CCS protocol family, with eventually then moving on to MCS once we kind of regularly get into megawatt charging stations. Now, for us, we have seen there's also a general push to kind of electrify airports. And it isn't just sort of to support eVTOLs, but all these support vehicles at airports are going to be electrified in the very near future as well. So there is going to be a need for these charging stations to be multimodal. And as Andrew was discussing before, and I'm sure as everyone has thought of, we can't have a dozen different or even 5 different charging protocols and different charging types at an airport or any location for that matter. It's just going to get very unwieldy, and it's not a sustainable model. So for us, we're working on, again, right now designing to the CCS standard. We are also working on a number of off-grid charging solutions and energy management systems. I can't get into too much of that right now without getting yelled at by my patent attorney. But we are in the patent application process on 4 different patents for our technology. With that, though, we are kind of multimodal compatible. Again, this is primarily for eVTOLs, but it is compatible with anyone that's going to be using a CCS protocol that needs very rapid charging. Our first generation charger is going to be up to 400 kilowatts, running off a basic 483 phase off the grid. We're going to be getting up to 750 kilowatts with our second generation. We do feel that's probably going to be sufficient. In conversations with some of the larger OEM manufacturers, there is a lot of talk about megawatt chargers and getting there and whatnot. Most of them, though, seem to be able to do a quick charge at about 700 kilowatts. So the whole need for megawatt charging is just a bunch of talk, it seems. They don't actually need it, which is good because it's ruinously expensive to try to integrate that. And just to generate that much power is absolutely extraordinary. So I'm hoping kind of cooler heads will ultimately prevail. We won't have to get to megawatts for a long time. 700 kilowatts seems to be sufficient to be able to quick charge the big guys in kind of 10 minutes or so, I think. So I believe for the foreseeable future, that's going to be absolutely more than sufficient. And also, thankfully, what's really fun, my engineers, who are way smarter than I am, have come up with a way to make our charging stations multi-protocol if necessary. We're seeing, again, based on conversations we've had with the FAA and some preliminary conversations we've had with the EASA, there isn't going to be one globally accepted standard for charging eVTOLs, and that's just sort of a reality I think we're going to have to deal with. But like every time I go to Europe, I got to take my little baggie of plug adapters and whatnot, because that's the way people are kind of utilizing electricity. I think there's going to be the same thing globally right now. There's going to be kind of super regional accepted protocols. There's going to be the Americas protocol, which is going to be a CCS version. Europe will come up with something. APAC will have something else. I know the guys at Electro.aero are talking about it. I believe it's SA 6869, if I remember correctly, is what that protocol is. I'm sorry, what was that? Nope, I thought I heard someone. Andrew, you're muted.
I think we're good. Sorry about that.
Okay, yeah, no worries. So it is one of the things. This will allow us to be able to integrate Volatus chargers kind of anywhere in the world. which is very handy. And so I'm very lucky I've got engineers who are that smart to be able to come up with these systems. So our energy solution, this is the very first box on the powder coat. It's already been delivered to the assembler, and kind of assembly and testing has begun. We are hoping to have that wrapped up by the end of Q2, but kind of the FAA will need to be making a few trips here to Wisconsin to check it out and run some additional tests. There is the OPCC standard and a few other things, and the underwriter UL has got some standards and whatnot for these types of things. So we don't know yet what the official kind of approval process for certification is going to be for these yet, but we're kind of going through all of them just to make sure we are going to be okay. But yeah, we are hoping this is going to be ready by the end of Q2. If not end of Q2, definitely sometime in Q3 without trying hard. So the off-grid power generation is where things get really, really entertaining. And this is where we're going to have the biggest issue, we believe, especially with some of the very high traffic routes in the very populous areas, like Archer has been talking about with New York and Chicago. I don't even know how many passengers a day they're going to be trying to move between the vertiports and the airports, but it's going to be hundreds of flights a day eventually. Well, now we're talking about we're going to need a lot of power. I mean, absolutely extraordinary amounts of power is going to be needed. And we're talking about maybe finally getting to the megawatt, but a dedicated substation for multiple megawatt chargers is going to be millions of dollars, just extraordinary amounts of money. So we're working on kind of fencing out and creating our off-grid solutions that can generate up to 7+ megawatts at 6,000 amps, which is an absolutely extraordinary amount of electricity, but that's what's going to be needed in order to make this work. Get to that point. It is probably going to be, 10, 15 years from now, but this is what the future is going to look like. And as I mentioned before, our current on-grid powers be able to push 400 kilowatts using basic 483 phase. And it is scalable. This is something we can actually kind of, with every generation, Gen 1 is up to 400. This can be easily scaled up or down, because I believe some of our customers like Air and whatnot, and also, in case you please correct me if I'm wrong, SkyDrive, you guys are only looking to be needing a 100 kilowatt charger, if I remember correctly. So this is something that can be kind of throttled up or down, and not just have sort of a one-size-fits-all approach, which is very helpful. So, but yeah, this is coming out. These are going to be ready to go to market this calendar year.
Outstanding. That's exciting.
Yeah. So I know it kind of threw a lot out there. Does, any questions, concerns, comments? Do you like the color of the thing?
And we'll also, in the interest of time as well, Grant, we could do one or two now. And I wanted to pivot to our video that we have from Electro.aero.
Perfect. Yep.
But anything quick before we do?
I can't seem to find the hands up thing, so I'll just throw in with a question. Hey, Grant, I was curious, when you think about when these things are fully operational, on one hand, there's the scenario of, plugging in, charging, turning it around, plug-in charging, versus, now you get a backup of them, and, maybe can you take out battery packs and charge the battery packs, and now it's a swapping of battery packs. Any thoughts on and what you envision that operation? Can you charge them fast enough with the inline systems that you're putting in place?
We do believe so. We've had conversations with a couple OEMs and also with the FAA on kind of one versus the other, kind of just plug-in charging versus battery packs. And the consensus, or I shouldn't say the consensus, but the opinion of the FAA is they're kind of leaning against battery packs. And again, it's just of, adding complexity to this. If the ultimate goal is this is to be as simple as gassing up your car, then swapping battery packs might be that step too far, and it's not going to work. So I think there's some questions that the industry needs to ask itself is, okay, what is the goal? How do we want to see these operate? And then, would, say, you and me be allowed to swap a battery pack out, or is it going to be a specialized technician who's going to require kind of OEM specific training to do that? Yeah. And how many people is that going to take? Then kind of extrapolate, going from there, how many batteries are we going to need to have at every single site? you know, how many dozens or hundreds of batteries are going to need to be trickle charging all the time in order to kind of make that viable.
And I do want to have time for more questions at the end. And I especially want to get on this topic because this is one I've been thinking about as well. So let's circle back to this. And I want to switch over to hear from Electro.aero. They sent us an excellent video. And I think I noticed that, do we have Dr. Rudd on with us?
Yeah, hello, Andrew.
Hello, I can't believe
How are you?
what is it? Is it almost midnight there? Thank you for joining.
Yeah, it's 11:20 here, Perth time.
Thank you for staying up late for us. We really appreciate it.
Thanks for having us. One of my colleagues, Richie, also is online.
Oh,
so
excellent.
We best try our best to be online.
Yeah, well, I really appreciate it. I'm just spooling up the video now, and let me know if you can see. Can anyone see the screen yet?
Yeah.
Yeah, we can.
Okay, great. And Dr. Rudd, did you want to do an intro before I hit the play button?
And I think that we include everything in the video.
It's a great video. I'm thrilled about this. I think everybody's going to enjoy it.
Yeah, cheers. Thank you.
All right. Unless there's anything else, I'll hit the play button.
Yeah.
Okay. Thank you very much for this contribution.
Hi, my name's Joshua Portlock. I'm the CTO and co-founder at Electro.aero in Perth, Western Australia. We're looking forward to sharing with you what we do in electric aviation charging and infrastructure. The electric aviation revolution is coming, and we are going to need high power, standardized charging infrastructure to scale with global demand. Aviation charging is very different to automotive charging. Aircraft can't drive right up to the charger like a car can. It has much larger wingspans to deal with. And really you need to move the charger and plug to the aircraft because they're often out on the apron. You'll have half a dozen aircraft that might be in the way, and you want to make sure that you can, as quickly as possible, start charging an aircraft between sorties rather than having them queue up and wait like you might be able to justify with cars. The other problems is cable thickness and weight. Anything over 60, 80 kilowatts starts to be pretty cumbersome to transport the cable. And the manual handling and bending radiuses can be a challenge too. The cables drag along the ground and can wear out. Unwinding and rewinding cables can be tedious and time consuming. And the problems are acceptable in the light duty side of aircraft charging, but they really need to be solved for commercial operations. For commercial aircraft that are eVTOL or have many seats for passengers in fixed wing, you are going to need to have a high-powered cable and charging management system to move up and back to the aircraft, and that's what we've been focusing on. Electro.aero was founded in 2016 with a focus on propelling sustainable aviation. We've developed electric ducted fan VTOL aircraft in the past in partnership with many companies, and we've developed electric propulsion safety systems for the likes of NASA's X-57 project, worked with Bell on many subscale projects, and XTI as well. So from that vertical integration experience, we understand the challenges of electric propulsion development, but most importantly, the need for standardization around aviation charging. We also gained a lot of experience as the world's first operator of commercial electric training aircraft, the Pipistrel Alpha Electro, back in 2018. And we founded the committee in that year for SAE AE7D as well, so that we could develop aircraft charging standards. Since then, we've built and flown the world's first ducted fan microlight and developed the prop-to-plug electric propulsion system, including the fast charging system with a 2-to-1 charge to flight power ratio. And we've been developing a growing line of portable and light chargers for aviation, adopting the SAE AS6968 standard we've been developing. So why should aircraft standardize? There's more than half a dozen different DC fast charging standards in the world for cars. Now that's fine if you are a Tesla and you're building millions of cars and you have hundreds of engineers and you cater for all those different standards when you ship your cars around the world. But when you're an aircraft manufacturer and you're a low volume production and you do have an international market immediately, there's also an international reselling market of aircraft that's quite strong. You do want that same aircraft to be able to charge with the same standard anywhere in the world. And as the aircraft range gets longer, you want to be able to fly between regions, between countries, without having to use adapters and carry additional charging hardware with you. So out of the automotive charging plugs we assessed 4 years ago, CHAdeMO had some maturity from Japan, and that has been still used to this day for Nissan Leafs and a few other manufacturers, but it's definitely a fading standard, and it's sort of conceding defeat to the other standards. CCS 1 and 2 was later to the game, but it basically combined the idea of an AC plug and a DC plug, which does make sense for automotive because you want to have low power charging at night and opportunistically when you're at work and whatnot, but you don't necessarily need that in aircraft. And aircraft can't necessarily justify the weight and complexity and cost of the combined plug and the extra AC to DC converter on board as well. Aircraft are very weight sensitive, so any weight savings is a real performance improvement. For their international markets, Tesla employed a modification on the Meneses Type 2 AC three-phase plug. So in Europe and Australia, we use the same three-phase AC plug for DC fast charging older Teslas, Model X, Model S, anything over about 4 years old. With that, you have to have a complex array of contactors on board the car, or if you're using it in an aircraft, that changes the use of those pins from AC to DC. So that's more weight, cost, complexity on board the vehicle that you wouldn't need if you just focused on DC charging only. In the automotive industry, there's a lot of adapters out there, and some are illegal and not recommended from a safety point of view. It's something you want to avoid in aviation. If you don't want to have to carry around extra things. In China, they developed the GBT DC fast charging standard, and that was taking all the lessons learned from the other DC fast charging standards and getting the best of all worlds, in the sense that it's a 1,000 volt cable, 250 amps without liquid cooling, 600 amps with liquid cooling, and auxiliary power pins for low voltage charging as well. Most of the other standards don't allow auxiliary power charging, and that is a real benefit, again, a weight and cost saving for aircraft to not have to have as oversized DC to DC or a separate way of charging the auxiliary battery system. CAN bus is also a versatile communication protocol that aviation industry is very familiar with, whereas PLC is a bit foreign to the aviation community and would be an additional module to communicate to CCS 1 or 2. Lastly, the form factor is a lot more compact without the AC coupler above the CCS 1 or 2. And the inlet is a lot simpler because it doesn't have a locking mechanism like CCS2. The lock is on the plug, and that means it's more serviceable and reliable for the aircraft without having the extra complexity, cost and weight on the aircraft. The other benefit is that GBT is quite commonly used on buses in dual pairs. It's very common to see a bus charging system dual DC non-liquid cooled cables to get the equivalent of a liquid cooled cable and save a lot of cost. So that versatility of 1 or 2 inlets has already been fully being utilized in buses and trucks in China. So it's a very easy thing to justify utilizing in aviation as well. So what have we been doing about it? We've been developing light and portable chargers for the aviation development community, including our 7 kilowatt light charger, which is quite compact and equivalent to a level 2 charger. If you plugged it into a standard single phase outlet, you'd have up to 7 kilowatts of charging, and we can throttle down the power for lower AC outlets. The 30 kilowatt rapid charger is our entry-level 3-phase charger. It runs off a 50 amp outlet, whether it's a standard California plug in the US or up to the 63 amp plugs in Europe. In Australia, 50 amps is quite common as well. So being able to just run off a standard 3-phase outlet and relatively fast charge a light aircraft or maybe slow charge an eVTOL aircraft, it's been a good versatile first minimum viable product, and we're quite happy with how that's been received in the industry. We also developed an electro management system, which is the brains of our charging system. It's on our latest smart chargers, as well as selling it to aircraft manufacturers to install it on the dash or the inlet, allow them to rapidly adopt AS6968 and work with their preferred battery management system to communicate to the redundant battery pairs and decide when the contactors will be closed for redundant battery charging. In larger eVTOL and mini liner aircraft, we're mounting these on the outside of the aircraft because they're daylight visible and waterproof. The EMS can serve as an inlet management system on the outside of aircraft to allow the charging crew to quickly see the state of the batteries and decide whether it's at the capacity required for the next mission without having to climb into the cockpit and monitor the displays there. The inlet management system can be used by ground crew to monitor the charge and decide when to finish charging to allow the aircraft to be operated. Therefore, the pilots can focus on piloting, the ground crew can focus on charging, and the operation can be a lot more time efficient. More recently, we've launched our rapid 80 kilowatt portable charger, And this is a smart charger with our EMS system built in, including cloud telematics over our ElectroLink. Through the ElectroLink cloud solution, we can do remote monitoring, billing, and maintenance, including over-the-air updates. Since integrating this IoT system is future-proofing us to things like auto billing and more sophisticated scheduling of the chargers, these are what we see as the scalable solution for aprons of airports around the world. So people often ask us what's the difference between AS6968 and GBT. Well, GBT as an automotive coupler was designed for 12 volts auxiliary power to the cars and 24 volts auxiliary power to the buses. We're going straight to 28 volts, which is a more common voltage in aircraft stingers to charge their auxiliary batteries. And by doing this, it's still within the 30 volt tolerance that cars and buses need to accept in the original GBT standard, but allows aircraft to be selective about only using AS6968 chargers rather than being backwards compatible with GBT. So we're forwards compatible with cars using AS6968, but not backwards compatible with aircraft using GBT. Because aircraft can do a simple check of, say, 26 volts or more, and that'll be in that threshold of 28 volts for aircraft only. Below 26 volts, they can preclude the use of an automotive or bus charger and not start the charge. Furthermore, we have added more packets around the optional voltage and temperature of the batteries, because the original automotive GBT standard only catered for up to 255 cell voltages and temperatures, whereas aircraft have at least 2 redundant batteries typically. So we've catered up to 1,500 cells in the packets for voltages and temperatures. And this packet structure can be also a software check to see if it's an AS6968 communication protocol or a GBT. We've identified more than a dozen reasons why GBT is a better aircraft charging standard plug than the CCS1 or 2. Now, obviously, CCS1 and 2 makes a lot of sense for automotive charging where you want that auxiliary trickle charging, but it's added weight. So you've got the extra weight of the AC converter, but you've also got the extra weight in the inlet itself for the physical coupler. And on the CCS2 coupler, there's also a servo driver for locking, which can be a service and maintenance risk. The locking mechanism being on the plug for the GBT means that the inlet's a lot simpler, cheaper, and lighter, and the reliability and maintenance side of it is on the plug. Dual temperature monitoring both on the pins of the plug as well as the inlet gives you that redundant temperature monitoring. And the larger 12mm pins, which are still finger safe, are higher current capable without liquid cooling. So GBT can handle up to 250 amps without liquid cooling without exceeding 90 degrees, whereas the CCS1, CCS2 pins are 8.5mm and will get hotter for the same current rating. The CAN bus is very familiar in aviation and integrates much easier with less noise than PLC. MCS is also likely to be using CAN bus at this rate because they've identified concerns with PLC causing noise. The existing manufacturers are actually producing GBT in higher quantities than CCS1 and 2 combined by at least a factor of 10. So the accessibility of supply is there. And the 28 volts I discussed before is a lot more versatile than relying on DC to DC converters on board. And you can downsize your DC to DC converters, knowing that you can charge your auxiliary battery every time you charge your primary battery. The additional fault tolerance on the safety of the contactors means that we can power those charge contactors by the auxiliary power so that when the coupler is removed, there's no chance those contactors can be energized, even if there was a software fault. The backwards compatibility with GBT does mean that at least these same aircraft car chargers can opportunistically charge GBT cars in China and neighbouring countries. The last point to make is that charging can be restarted remotely with the GBT architecture because of that auxiliary power system, and that way we can choose to put an aircraft into idle sleep, fully off, yet still wake it up over the charger and start charging remotely if needed. One other difference that's slightly changed in AS6968 versus GBT is the fact that the 28 volts is applied as soon as you plug the coupler in. So it maximizes the speed at which the system can power up and start an automatic charge. The process in GBT is that you plug in and then you start the charge and then it powers the 28 volts. That can be extra time consuming if you're having to walk between the plug and the charger to start. So by us automatically starting the 28 volts as soon as it's detected the coupler is engaged, you can start powering up the aircraft and speed up that time to start charging. So what about megawatt charging, you ask? Beyond our 80 kilowatt portable rapid charger, we're already developing 200 and 400 kilowatt superchargers for eVTOL and mini-liner aircraft. And if you are running dual inlets, you could theoretically get up to 800 kilowatts of charging, as long as you're liquid cooling the inlets as well. The Char-in MCS group is now transitioning to a standard writing phase, and they're developing the J3271 for truck charging. The AR7357 is going to leverage this great work and utilize the physical coupler for aviation charging and refine it as needed. This coupler is capable of up to 1,000 amps inlet without liquid cooling, with enough heat sinking, but anything over 350 amps will require liquid cooling on the plug side. So for 500 plus kilowatt charging, you're typically going to have a liquid cooled cable, possibly non-liquid cooled inlet, up to a megawatt. And for greater than a megawatt, you'll need a liquid cooled inlet. They're claiming up to 3,000 amps, which will be for really large commercial airliners. But it's great that this one coupler gives you that range from half a megawatt to multi-megawatt. And that's going to be complementary to the AS6968, so sub half megawatt category. For light aircraft, sub 5-6 seater eVTOL and probably sub 9 seat fixed wing, we're still suggesting dual AS6968 inlets. That doesn't preclude you from also having an AIR 7357 inlet for megawatt charging. But for the 19-seat mini liners and the really large, powerful eVTOLs, they're likely to go straight to the megawatt charging coupler.
Over the last 4 or so years, we've been working hard on improving the draft AS6968 charging standard for light electric aircraft within the AE7D committee, which has now grown to more than 300 participants. Within Electro.aero, we've found majority industry adoption of the draft standard. However, we wanted to see what the committee and wider industry had to say. As you can see from our 21 participants in the survey, AS6968 draft light electric charging coupler was chosen as the preferred choice. Some of the other observations that came out of the survey were that 14 of the 16 commenters preferred the locking mechanism to be located on the charger plug. Of the sub 200 kilowatt coupler requirements, all but one preferred AS6968 as their first choice. In the higher power category, 3 preferred CCS1, 6 preferred AIR 7357 or MCS, and 2 proprietary solutions were preferred as they believed there was no ideal choice for charging electric aircraft. With momentum towards the draft AS6968 standard for light electric aircraft charging and some uncertainty around the megawatt power charging solutions, we developed charging infrastructure solutions for our partners based on their design requirements. Our rapid 240 kilowatt chargers provide the maximum charge through the AS6968 coupler before liquid cooling is required. Typically, a larger aircraft with batteries in the wings will have a charge inlet on each side of the aircraft to avoid charging imbalances and heavy connecting bus bars required for a single port charging. This effectively allows about 400 kilowatts of non-liquid cooled charging through the draft AS6968 standard. Our super 400 kilowatt chargers will include liquid cooling to achieve the high current flow required through a single human liftable charge connector. One of the key innovations of our Rapid 240 and Super 400 chargers is the unique cable management system, which effectively lays AC cable down along a 25-metre path. This gets the charger to within a few metres of a charging inlet on the aircraft, without breaching the required clearance zone at the landing site.
As we support more and more power for these electric aircraft and more aircraft being charged simultaneously, the real bottleneck in the charging infrastructure is the energy systems, where the energy is going to come from. So there's often limited amount of grid connectivity at airports. So adding energy storage systems to supplement the peak power is important, and obviously adding solar to recharge those energy storage systems is a sensible, cost-effective, renewable way of providing that energy. And it's a balancing act. You don't want to have too much solar and not use it. You don't have too much batteries and underutilize them. So you have to size these systems right for the energy demand of your fleet. That's what we're developing with these smart hangars, helping airports and aircraft manufacturers and operators size their solar and storage systems and smart communications between those systems to the chargers, so we're fully utilizing those in the most cost-effective way. you really want to make sure it's a scalable solution so you can grow your smart hangar capability as the fleet increases. So starting with an entry-level solution of say 30 kilowatts of solar and a 50 kilowatt inverter gives you that 80 kilowatt of off-grid peak power of sustainable energy, but you can always replicate that, multiply many in parallel, and many hangars aggregating their energy together, which is our virtual power plant. So a smart hangar is made up of more than half a dozen subsystems. So obviously our chargers and the smarts in them to communicate to the energy storage systems and the other renewable energy generation sources, but the solar inverters, the smart meters to monitor the grid and make sure you're not going to brown out the grid connection. The batteries can be very scalable to the point where you can start with, say, lithium phosphate batteries for affordable fixed energy storage systems, but then utilize repurposed aircraft batteries supplementing those batteries in the future. So this scalable battery architecture is really important for the future of airports. Now, the virtual power plant is the overlaying cloud software that communicates to all of the systems, including multiple different airport hangars, so that they can actually aggregate the power and share them. We're treating the EV chargers in the car park as lower priority loads. So if we're running out of power to the aircraft charger, we can reduce that car charging load temporarily to allow the DC fast charging of the aircraft and then bring them back online again when the aircraft are no longer demanding as much power. So this dynamic load management system is really important to maximize your sustainable energy consumption and minimize your capital expense for the solutions and upgrades. To give you an example of the monetization of these smart hangars, as well as the self-consumption and obviously the cost effectiveness of solar as an energy source, by being able to distribute the energy locally, you can actually peer-to-peer trade the energy with your neighbors so that you're sharing that excess energy and you're not having to oversize your solution. And if you do oversize your system, you can monetize it. So if you're future-proofing for more self-consumption, you can in the shorter term peer-to-peer trade, and vice versa. If you haven't upgraded your solar system yet, but you do want to run off renewable energy, you can be buying it locally from the embedded network. And we see smart hangar upgrades in 3 stages. First, you want to size a smart hangar for self-consumption for your existing loads, and ideally not necessarily exporting to the grid, just so that you're not having to worry about the energy trading yet. In a self-consumption mode, you might be only enough energy to power the first couple of aircraft, but you're covering all of your existing terminal loads, like your air conditioning and lighting and whatnot, with sustainable energy. By doing this, you're effectively doubling the power capability of your airport because you're aggregating the existing grid connection with your sustainable energy and storage systems. Stage 2 is once you have enough of those distributed energy solutions within the airport, you can trade peer-to-peer on the embedded network. And again, this just fully utilizes your excess solar with your neighbors rather than necessarily feeding it back into the main grid with minimal return on investment. And again, once you've aggregated enough of these energy storage and solar systems at the airport, you're now multi-megawatt capable of grid augmentation. So virtual power plant software can aggregate the distributed energy at an airport and allow peak demand and frequency control ancillary services to monetize the excess solar and storage capacity at the airport at a global level. You can also effectively be giving back to the community by providing battery backup systems for emergency services within the airport district. So what can we do for you? Well, if you're an aircraft designer or manufacturer, we can support you with AS6968 compatible charging hardware, inlet management software, and the total charging solution. If you are trying to deliver more and more power at a limited grid connection airport, we can also add energy storage systems, solar, and supplement that. Airports and vertiports, if you're looking at developing your infrastructure to future-proof electric aircraft, we can help you with our smart hangar solutions that are scalable and future-proof for the growing demand of electric aircraft charging needs.
Our company's mission is to provide top quality products and services to electric aircraft manufacturers, airport and vertiports worldwide. We continuously work towards enhancing the quality of our products, innovating new solutions, and refining our processes to deliver value and overcome the challenges in the electric aircraft charging industry. We thank you for the opportunity to participate in the VFS working group meetings, and we welcome any questions you may have. We are also open to discussing any future opportunities.
Dr. Rudd, that was magnificent, extremely comprehensive, and is giving us tremendous fuel for thought and discussion about what's next. But you and your team have been extremely busy.
Yes, indeed. Yeah. And thank you very much for the invitation. And we are really excited to be part of this working group.
Yes, well, you've been doing a tremendous amount, certainly taking a leadership position. You know, I dropped an article that I found in the chat notes. As an American, we're always in technology fast to react in some technologies and very slow in others. And worldwide, we're fairly slow in electrification and the switch to solar compared to some other countries. And so I'd wanted everybody to see this article about, because I was happy to see the reference to electric buses. This article is referencing there being 138,000 electric buses being purchased and added to fleets in China last year alone. That's not the whole fleet, that's just last year. So you're so right to, bring in lessons learned from what's happening there, just by virtue of the sheer volume of recharging that's happening for large vehicles. So, of course, there's a lot to be learned from that. And I hadn't thought of that until I saw you bring that up in your presentation.
Yeah, glad to hear that.
Yeah. Just many great topics covered there by Grant at Volatus and Dr. Rudd and her team at Electro.aero. Are there questions that people have that you'd like to bring up? I don't see any hands up yet, but there's so much to talk about here.
I just can see that someone asked, is there any link to the video we just watched?
Yeah, so and I'll let you answer that if you have a separate place. We're recording this call right now, so this will show up on the VFS working group #1 site. So you'll be able to watch this entire replay there. And I will drop the I'll drop the link in case anybody doesn't have it. And I also included it in the reminder email for this meeting. There we go. Thanks, Dan, for dropping that in there. So that in the next couple of days, hopefully we'll be able to post this meeting. What questions do we have about Danny? Do I see your hand up?
Thanks. By the way, both the presentations are super enlightening, and it made me think about, naively, I just in my mind saw the vertiports as, multiple OEMs coming in to charge out, but as I see more and more of presentations like this, you start thinking about the limited space on rooftops for the rooftop vertiports versus larger space, open area type of vertiports, but that kind of goes against the cost of space within cities, et cetera. And I was wondering, as all of you are thinking through this, do you think that the rooftop vertiports are going to be limited to one OEM, another rooftop, another OEM, as opposed to rooftops with being able to accommodate multiple types of eVTOLs coming in? Just wondering if there's specific attributes to one or the other that are starting to emerge as practical and required.
I'll take a stab at it if you want. We've looked at the rooftop one. We've chatted with some engineers. We've had a couple of kind of preliminary reports done as to kind of what it would take to kind of retrofit an existing building of various types. And I think kind of the rooftop kind of concept, I think in general is a bit moot at this point, just because it almost costs more money to retrofit an existing building than to build a new one with kind of the engineering in place to support a rooftop vertiport or any type of landing infrastructure for an eVTOL aircraft. I think if we're going to create one and create the correct building for that, I think it can easily support multiple types. It's just a matter of kind of understanding what is sort of the largest kind of dynamic loading that's going to kind of occur. So what is the largest vehicle theoretically that you'll be landing on it? And then just design for that, and anything beneath that can land there. I noticed there was a question about taking into consideration weather. When kind of designing all this, and kind of it's interesting on the ground versus on the rooftop. And I can be standing in my backyard, not feel a whisper of breeze, but 100, 150 feet above me, there could be 20, 30 knots without trying hard. So it's a matter of what do we design to, and is there going to need to be a specific solution to kind of higher up, either rooftop vertiports versus on the ground. And so yeah, we are working on the de-icing problem specifically. We're working on that right now. We're working on collecting data from OEMs to understand what their needs are and kind of what their airframes, props, motors, etc., are kind of designed for, and then work on a number of de-icing solutions with them that we're also going to be working on with a number of the airports. So there's a lot of unanswered questions yet for a lot of this, and we're kind of working our way through them. I know, Andrew, you mentioned earlier kind of a tug to move the tugs. That's another big one. It's amazing how many of these things are not designed with wheels. So it's a matter of being able to have to go underneath it and pick it up. And okay, you're going to pick up a vehicle with passengers or cargo and move it, a certain distance rather quickly, far more quickly than say an AGV would move something, automated guided vehicle. So there's, again, that's another big unanswered question that a lot of people are trying to figure out. There isn't a lot of data yet to say what kind of weather will or will not be kind of, we have to design to or how this is going to work. I know kind of flying in Oshkosh certain months out of the year is far different than say flying in Florida, certain months out of the year. So that is something we are going to have to figure out. And there's a lot of research going on with it, but there has been no conclusions drawn yet, other than rooftops are difficult and going to be expensive. Slightly long-winded, I apologize.
No, it's good intel. And this is a little off topic, but on the rooftop helipad topic, I dropped a link to a 10-minute mini documentary about why we've really struggled in the United States to develop and replicate rooftop helipads. And it tracks back to one accident that happened in the 70s, and zoning has been fairly prohibitive for rooftop in the US, versus if you look at a country like Brazil, they've been very open to it and use it very frequently and have a lot of helicopter traffic, especially in urban areas. So it's something, that's another thing on that topic that we need to kind of get around and push through. Any comments or answers from on that topic or ideas from the Electro.aero team?
Yeah, thank you, Colin. Is it Colin or?
No, so my name is Grant. It's Colin.
Yeah,
so we got
up.
Zoom during the pandemic for my son.
Well,
so
thanks,
just
Grant.
haven't bothered changing it yet.
Yeah, no worries. Appreciated your presentation and what you're doing, and the more companies are tackling these problems, the better. So it's really great to see other minds working on these problems. I think from a standards point of view, we've really struggled to know whether all chargers should be capable of a big range of, say, temperatures, and that is standardized from your -30 to 40 regions to some of the regions in Australia, which are 50 degrees on the tarmac. How do we deal with such a discrepancy? And the same thing could be said for weather. Most of our chargers we're sort of aiming around the IP65, but we've been told that in some situations, like for example a hybrid situation, you might be charging while the prop's still running, and you need to have extremely high ratings for blasted wind and rain and all that sort of thing. So a lot of our chargers might end up being IP67, and that's what we're sort of hearing. And then there's the impact ratings that go with that and all that. So it's definitely we don't really know yet, but the feedback we're getting is that the higher ratings are important. Of course, there's then a trade-off to the weight gets heavier. There's ways you need to remove the heat and all that sort of stuff. So something that wasn't touched on much in this is the liquid cooling side of things. And as we get into the higher power levels, a lot of higher powered requirement eVTOLs and mini airliners are, they're requesting some purged fluid cooling for their batteries while they're being charged at these high C charge rates. And so that's another big challenge hasn't sort of come up in these conversations yet, that should there be a standardized solution for that, or a standardized way of doing purged liquid cooling, and how do we approach that? Or do we just accept that that won't be a standardized part, and if there isn't your manufacturer's liquid cooling supply alongside the charger in a vertiport, then you just charge at a lower charge rate, which those batteries are happy at. So there's that whole side of things as well. And the last point that wasn't really talked about much in the videos, we do know that many areas in airports, and maybe the whole airport, I'm not sure, on the air side, you can't just lay live cables along the tarmac like we've proposed for those dual chargers. So that creates an interesting problem, because the only way then you could really charge one of these vehicles is to lay, in the tarmac itself, and then have pop-up ports that then you plug into, which is quite a manual handling process, and creates a whole bunch of other questions. So it's definitely a challenging problem, and different partners around the world. Like we do some work with some partners in the US, but I'd say we're also working with partners in Europe, and there's a lot of stronger push, at least for the AS6968 solution in light aircraft there. I guess because the CCS1 isn't utilized there, and that maybe they feel is a better fit for what they're working on. And we're getting a lot of traction, I guess, designing unique solutions for these high-powered applications. But as you mentioned, Grant, there's a lot of uncertainty. A lot of it's relying on, FAA and EASA rules and how that plays out in the industry. So we're just trying to be flexible and realize that we might not have all the answers, and trying to innovate as we go, like I'm sure your team is, and see what we can make happen.
Yep.
Richie, I was just going to say that one of the impressive things and important things is that you reached out to the OEMs. You said, look, let's collaborate on this. We want to hear what you need so that we're creating a product that fits your designs. Sorry, Greg, go ahead.
Well, yeah, no, that's what I was going to say. I mean, that's one thing we're lacking at, is more data from the OEMs. That's what we need, I think, more than anything. And that's going to help kind of sort a lot of this out, is data from them. What are their needs? And it's amazing how many of them are not big on talking yet. The first round of vehicles are supposed to be getting their certification in, let's be honest, 18 months or so. And we still don't know what they need. So we can't kind of continue to move forward. Us, Electro.aero, anyone who's on the charging and infrastructure side, we can only move forward so far until we get more information and more data from the OEMs who understand what their needs are.
And they may be sorting that out on the fly as well.
There's a lot of sorting this out on the fly.
How onboard aircraft, the internal generators on aircraft are 400 hertz. And when I first learned that, it really surprised me. How do you get a global solution that standardizes to a completely different frequency to, standard electricity supplies of 50, 60 hertz around the world? And I guess the answer was that the generators on board the aircraft can be smaller. And so everyone decided, all right, we're going to use that, even though no one really is using it in infrastructure. And I think a lot of these solutions, we can have that same mindset, that the solution kind of comes from the low weight optimization on the aircraft. And it might not necessarily be the obvious one. And it might not actually be the easiest, as we've found, there's initially a strong push towards the CCS standards in the US. And then looking into it a little closer, some have decided internally that maybe it's not the best solution because of the weight and the certification and the noise tolerance of PLC and all that sort of stuff. So it's an interesting challenge. The other thing we found is a lot of aircraft are saying, hey, it's up to the airports to sort of sort out your own charges and infrastructure and power backups and deal with the power quality issues that will emerge from sawtooth charging and all this. And then the airports are saying, all right, which charges should we get? And the aircrafts are not really communicating that that lack of communication properly at this stage. So we're sort of caught in the middle saying, are you guys having these conversations? Because we're not hearing them come through each year. So there's a lot of work to be done on finding that middle ground and finding not only something that's going to sort of work short term in the local jurisdictions, but you know, a long-term global solution that will really reduce the number of you know, couplers and inlets and things like that.
And thank you, Richie. And that brings us up to time. We're it's actually midnight where Richie and Roya are. So we should all thank them very much for staying up late for us. Wonderful video, excellent follow-up, great work that your team's been doing. Similarly, Grant and your team at Volatus, you guys have been hustling on all sorts of infrastructure solutions, and you know, kudos to you for building out a charger infrastructure and working on that angle as well. So clearly a lot of collaboration and communication to be done in the future, but so much success that I'm seeing has already occurred, and things are farther along than I had thought and hoped, thanks to all of your hard work. So really well done on behalf of all of us. Thank you for your contribution today.
Yeah, thank you.
Thank you
for
very
the time.
Well done.
Best.
Thank you, everyone.